Okay, let's talk about piecewise continuous function. Well, actually, this is the main part of the Laplace transform because, in the previous method, my right-hand side must be continuous, right? But with Laplace transform, and we can solve the differential equation, even your right-hand side is piecewise continuous function. That's why we're going to talk about the definition of piecewise continuous function, okay? And it is like kind of like a little bit different with continuous, but if you have like just continuous function, definitely it is continuous, okay? Piecewise continuous as well. But what about piecewise continuous function? It could be discontinuous as long as you have finite number discontinuous point. Is that okay? Then since you have like finite number of discontinuous point, and you're gonna have finite number of subinterval, does it make sense? And the endpoints of each subinterval must be finite. Okay, which means there's no vertical asymptote. As long as there is no vertical asymptote, we're going to say it is piecewise continuous function. Okay, let me give you a couple of obvious example. The first one is this one. You have just continuous function between A to B. It is obviously something like that. And there is another function value, but it is still discontinuous with that. Let's say this is T2 and the endpoint is B, okay? Between A to B, there are three subinterval, right? Definitely this is discontinuous, right? But we can say it is piecewise continuous, okay? Because first subinterval is continuous, continuous, and continuous, okay? Endpoints, the limit of endpoint is just finite, which means there is no vertical asymptote. So this we can say this is piecewise continuous, okay? What about the the piecewise continuous failed case? As I told you, whenever you have vertical asymptote, it is fail. This is fine. But if you have like this guy, which is vertical asymptote, it's neither case. Does it make sense? Let me give you one example. Much easier to understand, okay? So what about this one? Let me try to sketch the graph of this one, okay? Here we go. It's just take here step by step, okay? Here we go. First function it is defined between 0 to 1, right? Let me use the different color. And it is x, then 0 part is inclusive, and 1 is also inclusive, right? That is 1. And second function, 3 minus x, right? When you plug in 1, it is 2. But it's not inclusive. And when plugging 2, it is 1. It's inclusive, like that. Then 2 to 3 is just straight line, which is 1, right? So look at that. This function, as you can see, there are two sections, right? From 0 to 1 and 1 to 3, okay? So it is definitely discontinuous, but in each subinterval, it is continuous, right? And also your endpoint, the limited endpoint is a finite. So that's why we can say it is piecewise continuous function. Okay.